if we look at materials from a physics perspective, there are two main properties. One is very familiar, is the mass of an object. And the mass we typically denote with the letter m, and we measure it in kilograms. The other property is the charge. And the charge I will denote with the letter q. Now mass governs all the mechanical movement and mechanical forces between particles. Charge is in the domain of electrodynamics. So the magnitude of the charge we measure in units of coulomb. And coulomb we abbreviate with the letter C. Now an important characteristic of charge is that it can be positively or negatively charged. It has a polarity, contrary to the mass, which is always positive. If we have a certain charge on an object, it is always discretized. That means if we take away charge, we cannot go on infinitely, but there's a teeny tiny amount of charge that is the smallest amount of charge that we can have on an object. This charge we call the elementary charge. And the magnitude of the elementary charge we denote with the letter E is equal to 1.6 times 10 to the power minus 19 coulomb. And we know this elementary charge from the charge of an electron and the charge of a proton. So if we have an electron, it contains the elementary charge in minus form. So the charge of an electron is minus E. The charge of a proton, on the other hand, is equal to plus E. And the proton and the electron govern the dynamics of the atoms. So protons are located in the nucleus of the electron together with neutrons that bind them together, and the electrons circle around the nucleus. So because of the plus and minus character of charge, so this is always in plus minus form, the interaction between charges depends on their polarity. So if we would have two charges, I will draw here a positive charge and a positive charge here. These two charges will repel. So like charges repel each other. So this particle will feel a force pushing it away from the other charged particle, and this particle will also feel a force pushing away. Now if we draw a third particle, so I add a negatively charged particle here, then the positive and a negative particle will attract each other. So this particle will feel a force in this direction, this particle will feel a force in this direction. And also the particle here will be attracted to the negatively charged particle, and a negatively charged particle will be attracted to the positively charged particle. And we can also always find the total force on a particle by vector summation. So the total force in this case will be pointing in this direction. Now the last thing I want to discuss in this video is the magnitude, the relation for the magnitude of this force, and that is given by Coulomb's law. And Coulomb's law states that the magnitude of the force between two charged particles equals a constant. In this case I denote it with K, times the magnitude of the first particle. So in this case we have first particle here, and the magnitude of the charge on the second particle, Q2. So it's the product of the two divided by the square of the distance r between the two particles. So this is r1, 2. Now the constant k that we have in here has a value of approximately 9 times 10 to the power 9, and then in unit Newton meter square over coulomb. The important thing to note here is that the force F depends on the magnitude of the charges. So if the magnitude of one charge increases, the force increases, but it depends inversely quadratic on the distance. So the further the particles are apart, the more rapidly the force decays.